Okay, so now what we're going to look at is when we have multiple activities. Before we were just saying just crash one, but that might not be the case. And in like real life, they might start saying, oh, we're going to crash multiple activities. So then we've got to make sure we're taking into account all those things. So usually you are allowed to reduce multiple activities in order to achieve the greatest reduction time. Using the table method is the best option for this, particularly when you have multiple. So first of all, identify all your paths. This is what we do in the table option. Then apply all possible reductions and update your times. So we'll see that. And then we check to see which reductions are required. And so this will make us, at the cost. We have to look at the costing as well. So this will make sense once we do a bit of examples. So we're reducing multiple activities. So activities R, W, and X can be reduced by a maximum of 2 weeks. So we can reduce them by 2 weeks. And it says what combination of reductions. So they're not saying single now. They're saying what combinations should be applied to achieve the best reduction in the overall completion time. So here we're going to write our first step, remember, is to write all the paths. So you write out all possible paths from start to finish, yeah? From start to finish. And then I've already done that to help us like get through it a bit quicker. So these are all the possible paths there. So if we just looked at all that, what's our original earliest completion time? What's the 26. We've got to take the biggest one, remember? So 26 is the critical path. So here, if you want to write that, so in green is the original critical path. So let's go highlight that up on our network. So we know that the critical path is the R, the U, we went through the user dummy, and then we went X, and then we went Z. So that is the critical path. So if you look at the original time, so now what we're going to do is we're going to apply these crashes, or here are the crashes. So our crashes, they said we could take away a maximum of 2 weeks of R, W, and X. So what you could do is you go into your table and just highlight when you see those letters. So I've got an X there, an X there, an R and an X there, and an R and a W there. So depending on how many highlighted I've got, so in the first one there's one letter highlighted, so I'll take away 2 because they're all that. So this one becomes 22. In the next one there's one highlighted, so I'll take away 2, so that becomes 23. In the next one there's 2, so R and X, so that would be take away 4, so this one becomes 22. And then in the last one I'm going to take away actually, can we fix this? This is actually 25. That was wrongly correctly. If you check that that pathway, that is actually 25. So if we take it away, what do we get? We get 4, we'll get 21. So our new critical path is here, up here. All right, so what you need to do, now you know that the critical path is 23, you need to look at what needs to be done to the original paths to get them to 23, because now that's what our new crashing time is. So we'll just write that as a note. So we need to look at what needs to be crashed or done to bring original path times to the value of new critical path. So what I mean by that, so here's our new critical path at 23. So if you look at this first one, to get 24 to 23, what do we need to do? We need to take away what? 1. We just need to take 1 away, don't we? So what can we crash there? We can crash x, yeah? So to get 24 to 23, we would probably have to crash at least 1x, yeah? Okay, if you look at the next one, 25, to get 25 to 23, what's that going to do? What do you need to do? We have to take x by 2. Now, because we've got to take 2, that means in the end, we would have taken the 2 up there, okay? So x is covered. We've covered that first one as well by taking 2. All right, so then if you look at the next one, to get 26 to 23, we need to take away, don't we? We need to minus 3 weeks. So we've already taken 2 with x. So now what else could I do? I need to take, I'll take 1r. Yeah, and that will be 3 weeks I've covered for that. And then what about 25? To get to 23, I need to minus 2. So what would that be? Which one do you think I'll use? Will I use R or W? Yeah, we've already used, yes, it does matter because these will come at a cost. So if I've already got to use R, I'll use that R for that situation. So I'll use R here. So now it's actually come to, we need to use 2 for R and we need to use 2 for X. So the answer here will be, we will reduce X by 2 weeks and R by 2 weeks. And that will give us the best reduction in overall completion time. So now we're going to have costs. So sometimes some activities cost less to crash than others. And so that's going to be very important to take into account because businesses don't want to spend if they don't have to. So in most instances, reducing activities will come with an associated cost. So here's an example. The completion times for activities E, F, G, I, and J can be reduced by 1 day. So they're saying we can take away 1 day there. And the cost of reducing the completion time by 1 day for these activities is shown in the table below. So that's here. They're showing you. So if I reduce E by a day, it's going to cost this company $3,000. So, and so on. So if you look at it, obviously if I crash F, that's a cheap one. So, you look for that. All right. So the first thing we've got to do is, and the question obviously is here, is what is the minimum cost to complete the project in the shortest time? So we're crashing this and we want to do it. So what do we do when we crash? We find, first of all, we find all the possible paths. So remember I did it the other day. So I'm going to start going through all of them. So say that's my first one, A, D, K. And if you add up those times, it's 14. Then I'm just going to rub that out, and then I won't keep highlighting all of them, but you'll see what I'm talking about. My next one, I'll go A, E, I, K, like that. And that's how I'm writing the next one, A, E, I, and K. And then I would probably move to the B ones now. So I'll go straight across, B, F, L. And then the next one I could do is C, G, J, and M. And then the bottom one, C, H, and M. Sorry, and I should have been adding up the time. So I'll go back to E, A, E, I, K would be, what's that, 14? No, 15? 15? Sorry. B, F, and L is 14. C, G, J, and M is 14. 14. And C, H, and M is 13. All right. So now we've got to do the crashes. Now, let's see. Remember, if we had any of the letters of these letters, E, F, G, and I, or J, they all can be taken away with one day. So let's go highlight them if I had them. So there's an E and an I here. There is an F here, a G there, and J, sorry, and there's nothing in the last one. Okay, so now that you've taken, you've highlighted where a crashing activity is, and we know we can take one away if it's highlighted. So the first one didn't change. The second one became 13 because there was 2 highlighted. The third one became 13 because there was 1. This one I need to take 2, and this one I didn't take any. So I should have checked out. The original critical path was 15, but now what's the new critical path? 14. All right, so now let's just first look at what we've got to do. So if you look at this first one, so to get its original time to the new critical time, this one we don't have to do anything. Now to get 15 to 14, I'll need to take away, what do I need to take away? One activity. So it could be either E or I, yes? So 15 has to go down to 14. So then that one, it could be E or I by 1. So we'll wait and see. Now, the next one, to get 14 to 14, I don't need. The next one, don't need anything. And 13's already under, so I don't need anything. So there's only one that needs to happen. Now, it's got to be E or I. So which one do you think we're going to pick? Why are we going to pick I? Yep, excellent. So I is 2,000, E is 3,000. So to get the best possible outcome here, we were just going to crash I by 1 day, and because it's cheaper. So we'll write that out as our answer. Okay, so therefore, we know it's I, and when they ask what's the minimum cost to do this completion, we're going to say it's 2,000 because I costs us 2,000 a day. All right, let's look at this one. So we're crashing one activity. So the directed network below shows a sequence of 8 activities to complete a project. The time in days that it takes is also shown. So write down the critical path. So we've done the table method down here. So what they did is they've written all the possible paths there. So we're going to let's have a look, and we'll just write them out in the table. So A, D, and H, that would take me 14. B, E, and G, going across that way, would be 13. And C, F, and 3 would be 16. So what is our first the critical path is the 16. So when you answer that, you just say C, F, G is what's the critical path. Now, what is the minimum completion time? We're just this was days, so we'll say 16 days. Okay, then in activity, it says then that activity F can be reduced by 3 days at a cost of $100 per day. Okay, so what is the new minimum completion time? So you can see we've got the paths here. So they sort of set up a table, so we can just write their original completion times. And then what they're saying is we can reduce F by 3. So find where F is. So then the new duration would be, this one would still be 14, this one would be 13, and this one would be 13. So the new completion time is 14. So what did we need to do to get 16 to 14? We would have had to take away 2. So really, so if we might, so with this one, so we can see that we'd have to minus 2. So what they did it over here. They had their original completion times, 14, 13, and 16. And then they just showed you if you reduced it by 2, F by 2, these ones would stay the same. And this one would be 14. So then that's all you need to do. So that it's sort of doing it a little bit like our pathway, our table way, but a little bit different. So we'd only need to reduce F by 2, so that would cost us $200. So what is the minimum completion time of the project is 14, and what would the cost be? If you want to write the cost would equal 200, because there's two days of F. All right, so it said the directed network below shows a sequence of 9 activities, and we've got the times to complete it. So it said the minimum completion time for this project was 28, and it is possible to reduce activities B, E, G, H, and I. And the completion time for each of these activities can be reduced by 2 days. So then it says, what is the new minimum completion time of the project? So when we have these crashing, this is called a crashing question. Our first step is to write all the possible paths. So here, and then so we can set up a table. Now they're not going to give you the table in the exam. You're just going to have to quickly rough one out so that you can get to the answer. So the first path that we could do, so I just like to go across the top, is going to be A, C, and E. And if you add up those those numbers, we get 27. Then if I go via A, but then go via the dummy, I could go F and H, and that one is 19. Then the next path I could choose is the B, D, F, and H. So that one is, and that one ends up being 28. And then the last one I could do is B, G, and I, and that one's 28. So this is where we can see that was good because we found out that it was 28. We actually have 2 critical paths. Okay, originally there's 2 critical paths. So way back in the first, when we first started talking about these crashing questions, we had this little note up here, and so I've brought it back into this one to remind us. So it says if there's multiple critical paths. So we do have multiple critical paths here. See how we've got 2? It says reducing any critical activity in isolation will not necessarily have an impact on the completion time. So it's more this thing. Only activities common to all critical paths will have a direct impact. So we just got to keep that in mind. So we're looking for, when we are crashing, we probably want to crash ones that are in both those critical, both those paths. So let's go. So what we normally do when we're crashing, so we've put the originals, then we're going to do the reductions. Now they said that we could reduce all these activities, B, G, H, I, by 2. So I'm just going to go highlight them. So all the times I see those letters. So B. Okay, so because they told us 2 up in the question, which is why I'm doing 2. Okay. And also G's one there. Okay, so what we're going to do, so we'll now reduce the time. So in this top one, the ACE, there's only E. So we can reduce E by 2. So it becomes 25. H we reduce by 2, so this one will become 17. This one, there's 2 of them, so I can reduce 2 by 2, so then that's 4. So this one becomes 24, and this one, because I can do all 3 of them by 2, it would become 22. Okay, so then what we've done is we find our new critical path. So the new critical path is actually A, C, E, and it takes 25 I think these were days, so 25 days. Okay, so then the question asks what's the new minimum completion time? So it's 25 days, and that's the actual path. And then it looks at, it says what will be the minimum cost that we can do this reduction in. So remember with the reductions, so we've got some costing up here, okay? And so this is what the activities, but first let's work out what we need to do. So remember the original times have to make it back down to this new one. So if I had to get 27 to 25, the only way I've got a -2, don't I? So if I'm minusing 2, and E is the only one I can crash, so I know I'm going to be crashing E by 2. So I'm taking 2 by E. Okay, in the next one, now 19, to get 19 to be under 25, it's already under 25. So really, I don't need to do anything to that one. So that one, it's okay. There would be nothing I'd have to crash. Okay, now this next one, now we have to get 28 down to 25. So really, we need to -3, don't we? And it'll be the same with the one underneath. Now, this is where we're saying there was multiple critical paths. So if you look there, we've got 28 and 28. So up here, this little note told us, it said only activities common to the critical paths, both the critical paths, will have a direct impact. So we would definitely need to use an activity that's common to both. So what's common to both of them? B. So we are going to use B when we're trying to get them down to the 25. So B we can reduce by 2. So so we'll use 2 of B's there. Okay, so if we've done that, we need to go, they actually need to be reduced by 3. So we've got to pick another activity. So up in this the third one, there's only H I can do. So I'm going to do 1 H there, yeah? Now, in the bottom one, I could do G or I could do I. So which one, because I've got a choice, I've got to crash one of them, so I'm crashing 3 days. So which one am I going to pick? I'm going to pick G. Why would I pick G? So G costs less, so I'll pick G by 1. So therefore, we now know all the costs we're going to do. So you can see up here in the answer, I've left the answer there. So we did E by 2 days. We had to do that. We have to do B by 2 days. Then we have H by 1 day and G by 1 day. So then if you add all them up, all right, so if we add these up, E by 2, so E costs 2,000. So we've got 2 of them. Then you've got to add a B by 2. So I think B was 1,500. Plus H, which was 900. And plus G, which was 700. So if you add all them up, that's going to be the total cost. Okay, so it ends up being 8,600 is the minimum cost. Okay, so just someone said, they looked at what they did. They said, up here, because H is cheaper, if we crashed H by 2 and B by 1, if you go down that path, that means you would have put B, you'd only have 1B here, and then you would have used 2G. When you actually do that, you'll find the cost is more than what you just found, okay? So the clue is, if you've got 2 critical paths, the ones that share in common it's going to have the biggest impact. It's because it's involving 2 pathways. You've got to wait for that B to be done before any of the rest of those paths. So it does work out. Any other situation, you're going to just have to check the costs. This is an activity. It shows the number of days to build a new hospital. So we've got all this. Now it says, what is the minimum completion time in the project? So what you want to be doing in your SACs and in your exams, you have read through this in reading time. And then down here, you can see they're doing crashing questions. So really at the first point, at here, we could do just tracking questions, where we do forward tracking, back tracking, and we would have found the the minimum time it takes. But because I can see down here, I've got to do crashing questions. That means I'm going to try and set up a table anyway. So I know the table shows me it'll show me the minimum time because I'll see the critical path. So I'm going to just go and do the table method straight off. All right, so when we go, the first step when we've got crashing questions is we've got to put all the paths in. So I'm doing the first top path when we could do A, C, D, G, I, and J. Okay, the next one could be B, G, H, I, and J. The next one could be B, E, H, I, and J. And the last one is B, F, J. Okay, so, and then if you go through and you add up those times, I'm just going to help you, we'll go a bit quicker. We'd get these times in here. So if you look, the original time, so the minimum time would be the critical path. So this answer, the first answer up here is 64 days. Okay, so now it says a number of these other reductions are possible, but each has a cost. So we've got a costing table there, so we'll have to be careful. And then it says these are the reductions. So you can reduce these activities. So if you looked up, if you want to just highlight them on there if you want, but it doesn't really matter. These are the activities that we can cut. Okay, so it says the original days. Don't worry about that. You just want to know how much they can be reduced by, which are here. So these are what you can minus away from them. So you can, all right, so we're going to, this is what we're going to minus from. So we'll be minusing 4 from A and all that. So once again, you are not getting the table. You'll never get given the table. You just have to create it. So obviously it's not going to be nice and neat like this, and that's okay. All you're going to do is just put, just do this. All right, you go your paths, you do that, yeah? And then you just write original times, and then what you're going to do is put your reductions, and then you're going to say. So here you can see I wrote them all out. I could minus A by 4, C by 6, E by 5. So this is upping it now. It's not just the same number they can get crashed by. They can get crashed all by different things. So once again, so you've got them, what you can crash it by, and then go highlight. So obviously all those letters that can be crashed, I'm just going to highlight to make it a bit easier. So if we go through all of them, so I've highlighted. So if you look in the first one, you can take 4 away for A, so that would be minus 4. C is minus 6, and I is minus 15. So the most you can take, you can take 25 off that. So 64 minus 25 is going to be 39, okay? With this I one, you're taking 15 away, so this one becomes 46. With the third one, E and I, so that is 5 plus 15, so you're taking 20 away. And then the last one, just F, which was 5, so you get 38. So our new minimum time, completion time, is going to be this 46. So now what we want to do is we want to get these numbers to 46, okay? So the original times to 46. So if you look at 64, we want to get it down to 39. So just to show you, you need to actually get, you're minusing 18 there. To go from 64 to 46. So I'll just write that. 64 minus 46 equals 18. So you know what I'm talking about. So I want to minus 18. So I'm going to use, if you have a look, I've got to use I. I'm going to use I. So I will be 15 of them. I'm going to use 15 of I. And then I've got to use, I need 3 more. So which one I could use C, or I could use A. And now if you look up, let's go look at the costs. Which ones am I going to use? C will cost me $100 a day. A will cost me $80 a day. What bill do you want to pay? $100 a day or $80 a day? What bill do you want to pay? $100 or 80? 80. So we want to go A by 3. Okay. The next one, to go from 61 to 46, that would be minusing 15. And we've got I in there, and so we've got to use all of I, all of our crashing of I. Okay, then the last one, the third one, we want to go from 63 to 46. That would be 17. Now we're already using I, so we'll chuck that in because that's an option. We've got 15 of them, and that means I have to use 2 of E because I've got to get it to 17. Okay, and E can be crashed by 5, but I only need 2 of them. And then the last one, if you look at this 43, it is already under 46, so it doesn't need to be done. Nothing needs to be done for that. You know, it's all good. So now you can see what you need to do. You need to reduce I by 15. So if you look at I costs you $50 a day. So 50 times 15. You need to reduce A by 3. So A costs you $80 a day. So 80 times 3. And then you need to reduce E by 2. And E costs us $40 a day. Okay, so this is going to be your minimum cost. You add all of them up, and you get a minimum cost of, I think it was $1,000.70. All right, so we've got another example, and we've got activities A to I are necessary to establish a garden. The directed graph of these activities and the time and hours are shown. What is the critical path? So let's just go and practice our forward and backward tracking again. So that's when, if you read through this one, you don't have to really do any crashing. So this is just like that previous chapter. So we're going to start it off. So this is where we go, you know, I'm going to put the boxes and I'm going to say H and I'm going to say A. All right. So that's 0 and that's 0. Okay, so we do that. We get up here to, now at this point here, we've actually got 3. We could go B, we could go G, or we could go C. So we all have to wait for A to happen. So that's 5, 5, and 5. Okay, if I go up here the E way, E would have had to wait for B. So 5 plus 6 is 11. If I go along here, D has to wait for C, so 5 plus 8 is 13. If I get to here, F has to wait for E, so 11 plus 4 is 15. And then, what are we doing? We're going to get to this point, I. Now, I's got a couple coming into it, so we've got to check. So 15 plus 9, 24 could be an option. Then we've got 5 plus 10 going the G way, 15 would be an option, or 13 plus 12, which is 25. So which one am I putting in there? 25, good. So that was, once I got there, that was the longest path to get there. So we can't keep going on I until D is finished, and then we get to the end. So 25 plus 8 would be 33. Once you get to the end, so what is the, you've got to go backwards because we need the critical path. So 33 minus 8 is 25. And now you go back via the pathways. So 25 minus 12 for D would be 13. If I do 25 minus, oh, wait a minute, I forgot. Remember H came out here too. Yeah? But it was, yeah, don't have to worry. But I'll go backwards via H. So 25 minus 7 would be 18. Okay. Now if I go 25 minus 9, what would that be? 16. 16 minus 4 would be 12, and then 12 minus 6. So going back via B will be 6. Now I'm going back to the I. So 25, I'll go to D. 13 minus 8 will be 5. Yeah? And that's going back via C. Or if I go back via G, 25 minus 10 will be 15. Okay? So we need to have them in case they ask me what a float time for one of the individuals are. Okay, and then going back, remember you picked the smallest. So C's the smallest, 5 in the red. And then 5 minus 5 is 0. So the ones that match up is A, C, D, I, and the N. So the critical path would have been along I, along D, along C, and back to A. So what's the critical path for this project? You'd have to write that out. A, C, D, and I. Okay, what's the shortest possible time to complete this project? You've just worked that out. 33 hours. Good, because they said hours up here. Okay. It said if the usual person who completes activity F is sick and her replacement takes 5 hours longer to complete this activity, what effect will this have on the project? So if you look at F, and she's going to take, F is sick and her replacement takes 5 hours longer to complete the activity. So if you're at F up here, you'd be at 15. Add on 5, that would get you to what? 20? Yeah? No, what would it do?
Wouldn't it have no effect because it's not the critical path?
Sorry, F. No, sorry, you've got to add on 5 more onto that. It will affect it. So if you're at F, she's going to take, what did it say? 4 hours or 5 hours more. So this is now going to take 14 hours. So what's 15 plus 14 would mean I get to 31. What did I say? Is that right? 15 plus 14 is 29, sorry. And then if you add the I, 29 plus 8 is 37. So it did increase the critical path. So what does it do? The 4 hours, it'd be 4 hours more. Even though she takes 5 hours, we went from taking 37 to be 4 hours more. Yep.
Don't you just minus it from the float time of the activity? I feel like if it was at...
No. Okay, and then if the replacement person at activity F is more efficient and completes the activity in 6 hours, so now so instead of the person normally takes 9, this person's more efficient and they will take 6. What effect will it have on the project? It won't have any effect, will it? Because it's not on the critical path and it's gone smaller. So that one will have no effect. Because it does not affect critical path. Because it's less and it was not on the critical path, so it's not going to affect it. Due to the reshuffle of staff, task G is now being done by the person who does task F. So if you look up here on the original, so G and F normally went in together, or had to be done before I. So because G has to be done by the people who do F, so what we need to do is G still has to come from B. G still has to be done after A. So what we're going to say is that it would have to go here. So instead of going along here, because it's got to be done by the people who do F. So we've changed it. So I've redrawn the diagram down here where I do that, where I put E in there, and now G's not doing that. So G is now being done by the person who does F. The person doing task C has been asked also to complete E. So this means C needs to be finished before E starts. Okay, so you can see nothing else is changing. So to connect E up to E and C up, to connect E and C up, so I'd have to do like that, and we don't do multi edges. So when you're seeing something like that's got to go on, you know it's a dummy path. So here's there where I put the dummy. So C will finish before E, and then E will start. Okay, so there's that. So then it says in the end, that says given the amount of time to complete those activities are the same, how long will it take to establish the garden? So you need to now go do your tracking through it. So here at the start, we have a H and we've got A, and they both go 0. And then when we get to here, we actually have, I'm going to put here C and E, and then up here I'll have the B one, B. So they all have to wait for A to finish, which is 5. Okay, and then we keep moving on. All right, so, actually, we've also got G here, and G has to wait for 5. All right, so off we go, and I might just go down along the bottom. So if I go along C, then D has to wait for C, so that will be 13, 5 plus 8. And then we'll get up to here, and this will be our I. So let's just put our options. So 13 plus 12. I'm just going to put them there because there's a few ways now. All right. So then if I look at here, E. Now E's got a few things happening now. It's got C and E. C and B, sorry. So if I went the B path, it'd be 5 plus 6, which is 11. If I went via C, it'll be... we get to here, so it'll be 13. So you end of C, which would be 13. So 5 plus the 8. So 13 smaller, that's why I put it in there, so we can get rid of that one. All right, and then we get down to, obviously we got F. Now F has a few leading in there. It could come via H, which would just be 7. It could come via G, which would be 5 plus 10, which is 15. It could come via E, which is 13 plus 4, which is 17. And then that's it. So we're going to say 17 is what's going into there. All right. And then we go down to I. So 17 plus 9 is 26. So this is actually the bigger one. So I'm now going to take 26 there, and I just rub them out. And then I get to, the finish. And the finish is 26 plus 8, which is 34. And I think they just said, you don't have to backtrack because it just said what's the minimum time. So these were, I can't remember, was this hours or days? Okay, it was hours. So 34 hours is the new establishing time.